Good day everyone, we are the group 11 and today we will discuss the control loops, control valves and regulator. So first, what is control loops? Control loops are like the brains behind making things work smoothly in factories and systems. They constantly check and adjust stuff to keep everything just right. So in the intricate choreography of industrial processes, control loop emerge as the conductor tirelessly orchestrating precision through feedback mechanism. These loops continuously monitor and adjust systems variables, be it in temperature, pressure, or flow, ensuring a harmonious dance of stability and optimal performance. So next is the control valve. So a device controlling fluid flows in industrial process by modulating its position in response to control signals. It regulates parameters such as flow rate, pressure, or temperature to maintain the desired set point. So ano nga ba ang control valve? So ang control valve ay mahalagang bahagi ng sistemang pang-industriya na nagbibigay daan sa kontrolado at maayos na paggalaw ng likido o gas sa loob ng isang sistema. Ang pangunahing layunin ng control valve ay ma-regulate ang daloy ng materyales sa isang proseso upang mapanatili ang itinakdang mga parameter ng sistema. May ilang pangunahing bahagi ng isang control valve. Una, mayroong valve body na siyang nagkontrol ng pagdaloy ng materyales. Ang actuator naman ay responsable sa paggawa ng kilos o pagbukas at pagsara ng valve. Ang positioner, kung mayroon man, ay nagbibigay ng masusing control sa posisyon ng valve batay sa feedback na matatanggap nito. Ang mga control valve ay karaniwang ginagamit sa industriya tulad ng petrolyo, chemical, enerhiya at tubig, kung saan ang wastong regulation o daloy ng likido o gas ay critical sa operasyon. Gamit ang mga ito, maaaring masunod ang mga itinakdang parameter tulad ng temperatura, pressure o flow rate sa isang sistema. So sunod, I'll give a brief explanation in the key terms. Here are the key terms associated with control valves and regulator in control loops. So first is the control valve so I discussed it, control valve device regulating fluid in a process. So next is actuator. Actuator is a component of converting control signal into valve movement. So ang actuator is the actuator is the dynamic force behind a mechanical system, translating control signals into physical motion, whether in the form of electric motors, hydraulic cylinders, or pneumatic devices. These components serve as the muscle, executing precise movement that drive the functionality of machinery and system across various industries. Actuators plays a pivotal role in automating processes, providing the necessary power to adjust valves, move equipment, or execute tasks, ultimately contributing to the efficiency and responsiveness of modern technological application. So next is the valve positioner. So the valve positioner is in the orchestration of industrial precision. It emerged as the maestro, fine-tuning the harmony of control valves, a critical conductor in the symphony of automated processes. It studies the nuisance dance of valve positions, providing a bridge between control signals and precise movements. With a keen focus on feedback and accuracy, the valve positioner ensures that the fluidic choreography adheres to the decades of meticulous steps, guiding the system with unwavering clarity and purpose. Sunod ang trim. Within the heart of control valves, the trim center stage, defining the intricacies of fluid flow regulation, comprising valve internals such as plugs, seats, and other components. The trim shapes the valve performance, influencing its ability to modulate and control the flow with precision. This internal configuration, meticulously designed, dedicates the efficiency, responsiveness, and reliability of the valve, making the trim a crucial determinant in the orchestration of fluid dynamics within industrial processes. So, sunod is the flow characteristic. The silent architects of fluid dynamics shape the behavior within control valves embrace, whether linear, equal percentage, or quick opening. These traits define how the valve modulates flow in response to change in position, influencing the relationship between valve opening and fluid rate. The choice of flow characteristic become the poet brush stroke, crafting a narrative of control and precision, guiding the dance of liquids and gases through industrial conduits with tailored grace and efficacy. And fail-safe in the realm of industrial assurance, fail-safe stands sentinel, a guardian against potential chaos. Designed as a safety net, it orchestrates control system to default to a secure state in the event of a failure, ensuring a resilience of process and mitigating risk like a vigilant sentinel. Fail-safe mechanism act as a reassuring presence, averting potential disruption and fortifying the reliability of integrated industrial system with a steadfast and proactive shield. So next is the regulator. So the stalwart architect of stability govern the equilibrium with industrial system, whether managing pressure, temperature, or flows. This steadfast component acts as a vigilant guardian, ensuring that the desired parameters are maintained amidst variable conditions, guided by precision and adaptability. Regulators play a pivotal role in optimizing efficiency, promoting safety, and fostering control in diverse industrial applications, where the influence resonates as cornerstone of operating reliability. And the set point is a beacon in the sea of control. Marks the desired target within industrial orchestration, like a compass for automated system. It signifies the optimal values for a given parameter, be it temperature, pressure, or another variable, guiding control mechanism to strive and for and maintain this predefined position. A lighthouse of precision, the set point anchors the dance of automations, providing a clear destination for process to navigate towards, ensuring stability and aligning the symphony of operation with predetermined excellence. Next, the sensing element. A vigilant sentinel in the realm of measurement captures the essence of industrial variables within precision. And now is the controller. Controller component adjusts output to maintain set point. And the PID controller is using proportional, integral, and derivative terms. And last is the dead time. This time delay between a change and the system response.
Actuator components converting control signal into valve movement. Actuator is a component within a control system that translates control signal into physical movement, typically responsible for adjusting the position of devices like valves or dampers to regulate a process variable. Actuator also helps it to achieve physical movements by converting energy, often electrical, air, or hydraulic, into mechanical force. For example, the actuator is like a door in a bus that automatically close or open.
Positioner, device integrated with control valves. to ensure accurate alignment between the valve's actual position and the desired position specified by the controller, enhancing overall system performance in the industrial process. Positioner. Example of positioner. Positioner like the ones you see here are devices that allow use to accurately throttle the control valve at a diagnosed styles are available depending on the type of control valve. You have all positioner. Required two things for proper cooperation. Input and feedback. Input is control signal that provides a set point feedback. Indicate the current valve position. Let's take a close look at position operation. And input is provided by pneumatic control signal to allow bellows. As input is increased, the bellows will expand and act on a beam. The beam pivots and moves a flapper in the rotation to a nozzle. The flapper position is changed, and the nozzle pressure changed, and operation and pneumatic relay. This point, we simplify have a pressure to pressure transducer for the input. To make it positioner, we must have feedback. The feedback ensures the control valve is responding to the input, and the valve position corresponds to the given input in this animation.
Air pressure regulators are pneumatic devices that have a function of reducing the air pressure. How air pressure regulators work? A pressure regulators reduce the supply of air pressure to a lower outlet pressure and maintain it despite fluctuation in the inlet pressure. Compressed air comes into through the inlet and blow out the regulator's outlet. Outlet pressure is made exactly the same as the set pressure. It's called is pressure equilibrium. The regulator are managed within half of a gauge and an adjusting knob. The pressure of air gauge is displayed the set and the current pressure, and the adjusting knob is used for manual pressure adjusting. Once the pressure is set to a lower pressure, the air pressure drops and vice versa.